Hello everyone and welcome to our presentation. My name is KATARI VEERENDRA VASU and I am here with my team member Thummaluri Vamsi. We are both from ECE branch from our respective colleges. Today we will be sharing our experience and project outcomes from the internship program we completed through Emertxe. And also I would like to express my sincere appreciation to our trainer Ms. Jaylakshmi and Daniel for her invaluable guidance, support and mentorship throughout our internship program. Before we dive into our project details, we would like to take a moment to acknowledge Emertxe, the organization that provided us with this valuable internship opportunity. Emertxe is a leading provider of innovative training and internship programs, and we are grateful for the experience and skills we gained through their guidance. Throughout our internship, we had the chance to work on a real world project, collaborate with our mentor, and also enhance our skills in embedded systems. We are excited to share our project outcomes with you today.
Hello everyone, myself Vamsi. From now, I will continue the presentation. These are the topics we learned during the internship. Let's start with C programming. What is C programming? C is a procedural language. It was initially developed by Dennis Rich in the year of 1972. And C is also a structural language, general purpose language, mother language. And the main feature of C language include low level memory access, a simple set of keywords. And this is the structure of C programming, which contains header, main function, variable declaration, and body. Coming to the features of C language, it is a middle level language, structure oriented language, portable. It means if you written the code for one computer, may also runs for the other computer also. Modularity. C is faster. Coming to the applications of C language, used in embedded system designing, operating systems, compiler design, database management applications, gaming applications, cloud servers, device drivers, and so on. These are the keywords in C language. There are totally 32 keywords. Coming to the operators. Operator symbol that tells to the compiler to perform the certain mathematical operation. Operators are classified into unary operator and binary operator, ternary operator. Again, they are classified into arithmetic operators, conditional operators, assignment operators, and like etc. Types of modifiers: short, long, signed, unsigned, wide. These are the compilation stages in C language. Source file, after the preprocessors, coming to the compiler, after that assembler linker, coming to the input and output functions. Printf function is the output function, the formatted output to the standard output. This is the syntax of printf function. And scanf function. It is the most used function to read the data from the user and stores the result into the given argument. This is the syntax of scanf function. Coming to the conditional statements in C language. We also consider decision making statements. Statement executes set of command like when condition is true. This is the syntax of if block. If condition is true, it will execute the if block. If fails, then it will execute the else if block. Coming to the switch case, a control statement that allows multi-way branching based on a variable. This is the syntax of switch case. Loops in C language. Loop is a block of statement that perform set of instructions. It iterate the block of code multiple times until fails the conditions. These are the three types of loops: while loop, do while loop, for loop. While loop, it is a entry control loop. First, it will check the condition, then it will execute the code. Do while loop, it is a exit control loop. First, it will do the operation, then it will check the condition. For loop is also a exit control loop. Overflow and underflow. Overflow occurs when the result of an operation exceeds the maximum value that a variable can hold. For example, if Unsigned char variable range is 0 to 255. If I assign the value 256, it will overflow. Underflow occurs when the result of operation is smaller than the minimum value that a variable can hold. For example, if a signed char variable range is minus 128 to 127, if I assign the value minus 127, it will underflow. This is the syntax of int max and int man are macros defined in limits.h header file. Coming to the arrays. Arrays is a collection of similar data types or collection of similar entities stored in contiguous memory location and also a collection of characters. Each of element of an array share a variable, but each element having different index number known as subscript. Index number starts from 0. This is the way of storing array elements. And this is the way of array declaring array. This is the way of initializing array. These are the syntaxes of array declaration and array initialization. Pointers. A pointer is a variable that stores the memory address of another variable. Instead of holding a direct value, it holds the address of where value is stored in the memory. The main two important operators in pointers are dereferencing operator and address operator. Dereferencing operator is used to access the value. Address operator is used to access the address of a variable to a pointer. Endianness. Endianness refers to the order in which bytes are arranged in memory. These are two types, big Indian and little Indian. Big Indian stores the MSB first. People who sense to read left to right. This is the way of arranging. Little Indian stores the LSB first. This means which makes most sense to people who read right to left. This is the way of arranging. Coming to the types of pointers. There are so many types of pointers: wide pointer, null pointer, wild pointer, dangling pointer, double pointer. Coming to the null and wild pointer. Null pointer is a pointer that pointing to nothing. Null is used to represent that there is no valid memory address. Syntax of this is the way of declaring null pointer. Wild pointer, a pointer that has not been initialized to anything, is known as wild pointer. This is the way of initializing wild pointer. Pass by value and pass by reference. Pass by value. When you use pass by value, the compiler copies a value of argument in a calling function to a corresponding non-pointer parameter in the called function definition. The parameter in the called function is initialized with the value of the passed argument. Pass by reference. In this method, the address of argument is passed to the function instead of passing arguments itself during the function call. Due to this, any changes made the function will be reflected in the original arguments. These are the syntax of function definition and function call. Here we are passing the arguments to the function. Passing array elements to the function. Passing array elements to the function is directly access and modify the original array. Returning array in C using pointers. One of the most common way to return an array from a function in C by using pointers. This is the way of returning arrays. Recursive function. A recursive function can be defined as a routine that calls itself directly or indirectly. Recursive call is nothing but calling a function within the function. Static variable. Static variable. This is the way of declaring the static variable. Static is nothing but it remains the value until the end of the program. Constant. Constant are read-only values that cannot be modified during the execution of program. This is the way of declaring constant. Strings. Strings in C programming is a sequence of characters terminated with a null character. This is the way of declaring a string. Storage classes. Storage classes define the lifetime, scope, and visibility of variables. These are the four types of storage classes: auto, static, external, register. Here we mention in table storage specifies storage, initial value, scope, lifetime. And coming to the preprocessor directives, preprocessor programs provide a preprocessor directives that tell to the compiler to preprocess the source code before compiling. All of this preprocess directive begins with hash symbol. Here we are mentioned. The hash symbol indicates that whatever the statement starts with hash symbol will go preprocessor program to be executed. Preprocessing like this it will execute the code. Coming to the macros. Macros is a piece of code in a program that is replaced the value of the macro. Macro is defined by hash defined direct. This is the way of declaring macros. Coming to the C outcomes. These are the outcomes. Okay. From now, my friend will continue the presentation.
Okay, everyone. Then we will talk about the embedded system. Embedded system is nothing but a type of electromechanical system. It is a combination of both hardware and software which is intended to design to do a specific task. It's called an embedded system. There are two categories in embedded systems. They are nothing but one standalone and another one is real time. Standalone is nothing but it can work by itself without like a processor or computer, without requiring a host like computer or processor. There are some examples for this like domestic appliances such as dishwasher, TVs and digital phones. And the another type is real time. It is a specialized computing system designed to task with a defined time constraint. Time constraint is very an important thing in this embedded systems design because there are also two types in this: hard real time and soft real time. Hard real time are nothing but they are time critical, and the soft real time is nothing but less time critical it was. And also the requirements of an embedded system is like reliability, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. Like when you want to design an embedded system, these are the things that you have to look out for. Okay, these are the components which are exist in an embedded system. Software, system on chip or a microcontroller, memory is an important thing, FPGA, field programmable gate array or ASIC design, and also diagnostic port, human interfaces. These all things are present in an embedded system. After that, when we talk about like what is microcontroller, it is nothing but an integrated circuit which is capable of being programmed to perform a specific task. The main thing about this also, all the peripherals are embedded on a single chip. So it was the major advantage for the microcontroller over the microprocessor. It also like normal restrictions are also there like memory size, input output capabilities and all of these things. After that, when we talk about this differences between microprocessor and microcontroller, I already said like embedded on a single chip, all the peripherals are embedded on a single chip in microcontroller, not in microprocessor. And also it was more flexible microcontroller, and also design complexity also less for a microcontroller, more design complexity for the microprocessor. And also these microcontrollers are used in designing for the embedded systems. These are the host, target and compiler for us. First thing, host, which is nothing but a board, PIC Genius board that we are using to develop the project here. And also target, we are loading the hex file into the PICSIM lab. And after that, we are using the cross compiler XC8, which is used to generate a code for the other architecture also, cross compiler. After that, uh, let's start with an introduction to PIC microcontroller. PIC stands for Programmable Interface Controller. It is a type of microcontroller developed by Microchip Technology. And also PIC microcontrollers are widely used in various applications including robotics, embedded systems and IoT devices also. It has 40 pins and also total 5 ports. It supports serial communication for which has 2 pins TX transmission and receiver pins. And also we have to place a crystal oscillator ranging from 4 MHz to 40 MHz. This was the block diagram of the PIC microcontroller we are using. These are the port configurations. It was having the PIC microcontroller was having a trace register, which is nothing but data driven resistor. It was, and also when we give a port register 1, then it will be act as input. If we give 0, like we are assigning 0 to it, it will act as a output. After that, when we talk about these LEDs, there are two types. One is current sourcing and the another one is current sinking, which is nothing but actually in current sourcing, the resistor and the pin is connected to the ground. In the current sinking, we connecting it to the plus 5 volts VDD. Our project begins with the basics, LEDs and tactile switches. The LED is nothing but a simplest device as a feedback. If the LED is nothing but a diode, right? If the diode is in forward bias, it works. If it is in reverse bias, it doesn't work. And also, the next slide. Okay. The next slide is about tactile switches. Tactile switches are nothing but they are one type of switches. Switches are defined as to control the circuit to turn on and off. There are so many types including this tactile also. There are push buttons and also toggle switches also present. Why we are using tactile switches means they are simple and cheap interface and they are also available in different shapes and sizes. And if we talk about the applications, the mobile phones, computer mouse and etc. so on. And also here the right side diagrams are nothing but we can connect that push button to the circuit in two ways. The first way is the left one and the second way is the second one. One is the pull up circuit and the other one is push down circuit. The both are. And also when we these are the triggering methods that we are using in switches. Triggering means nothing but to initiate something. Two types level triggering are there. Two types of triggering are there. One is level triggering and the another one is edge triggering. Level is nothing but to trigger the event based on the value, and edge is nothing but to trigger the event based on change in the value. For example, we can take as for level triggering, we can take the TV remote volume switch. For the example of edge triggering, we can take the power button. And applications where we use this triggering is nothing but doorbell, bike horn, and there are so many things are also. Applications are there. And also the main thing, the main thing about the switches are bouncing effects. To reduce these bouncing effects, we need to add a for loop delay. We need to add some delay. There are also another method is also there, but we prefer this delay method only. After that, matrix keypad. Matrix keypad is nothing but arrangement of switches in rows and columns. And also we can say that it acts as an input device, allowing the microcontroller to read the multiple buttons presses from a grid of buttons using only a few input pins. And the 4x4 matrix also can be connected in three modes: normal mode, pull up down and pull up down mode. After that, this is the configuration that we will know whether which switch is pressed, and also these all things we will get to know by this table only. Okay, next thing that we talk about is interrupts. Another important topic it is. We have covered is interrupts and interrupt service routine also. Interrupts are nothing but they are a signal that initiate changes in the normal program execution. The interrupt service routine is a function that handles the interrupt. We have implemented projects that demonstrate the use of interrupts and interrupt service routine. We are using this interrupts and interrupt service routine in our main project also, micro project also. The first thing it does is it acknowledges the request, attends the request and goes back to the processing where it was interrupted. This is the block diagram for an interrupt service routine. Peripheral devices, request, interrupt, it will goes to the control and also stop current task. Whatever task that was doing there, It will stop the current task temporarily and serve the interrupt. After serving the interrupt, it comes back to the same position and continues the execution. This is the interrupt service routine. The in intercon register, we are using three peripherals that we are using. So the first one is GIE, Global Interrupt Enable. If it is 1, it enables all the interrupts that are present in the microcontroller. If it is 0, it disables all the interrupts. And the second pin is nothing but PEIE, Peripheral Interrupt Enable bit. If it is 1, it enables all unmasked peripheral interrupts. If it is 0, disables all the thing. And the next one is TMR2AF, which is TMR to PR2 match interrupt flag bit. If it is equals to 1, then the TMR2 to PR2 match occurred. If it is 0, match was not occurred. So the next topic that we are going to explore is nothing but timers. Timers are nothing but they are default peripheral in microcontroller, which is used to calculate the time. The timers are also available in different sizes like 8-bit, 16-bit, 32-bit and 64-bit also. In the timer, there are particular two concepts, pre-scalar, scaling concepts, pre-scalar and post-scalar. Pre-scalar is used to scaling time taken by the tick. Post-scalar is nothing but scale after how many overflow interrupts will occur. These are the two things that are mainly in the timers. Scaling concepts they are. So this is the timer 2 block diagram. We are using timer 2 module because it was easy to use rather than timer 0 and timer 1. So that's why we are using timer 2. The timer 2 block diagram. In this block diagram, the TMR2 register will start from 0, 0. And the PR2 register is already assigned to FFH. So it calculates from 0, 0 to FF until it reaches. So after reaching the FFH, it resets to 0, 0 again. Okay, the next thing is CLCD. CLCD is nothing but character liquid crystal display. Actually, there are two types in LCD. One is CLCD and the another one is GLCD. So CLCD is nothing but for to display ASCII characters, calculators, and also multimeters or the applications for that. GLCD is used for small bar graphs and small images. We can say that the bike dashboard is an example for the GLCD. But for this project, we are using only CLCD, not GLCD. Introduction. It was having total 16 pins and the communication modes are also divided into two. One is 8-bit and the another one is 4-bit. So the CLCD also having variants like 16 cross 2 and 16 cross 4 and 16 cross 1, which is nothing but 16 cross 2 is nothing but it will display 16 characters for a single line. Like that the remaining also. And also these pins are, when we talk about these pins, it was also containing read-write pins, register select pins, V0 pins, D0 to D7 and also anode and cathode pins. These are connected to the microcontroller as we required. These are the commonly used LCDs, photos of it, and this is the connections that are present in the CLCD. Let's we discuss about the project that we did in the internship. So this is the project abstract. Actually, this project is based on a microwave oven, which is used in our daily routine. So microwave oven is proposed in which the food status determine the time for reheating or even cooking the food inside microwave oven instead of speculating the length of time required to achieve desired status. So this microwave oven is available in our household also, most of the households. So we decided to work on this project actually. So the next slide. Okay. To do this microwave oven project, we are using these things. These are the requirements of our project. The first thing is MPLAB IDE, which is available in the Chrome. We can download it for freely. It is okay. And the second thing is XE8 compiler that we are using to compile this code that we have written. And PIC Simlab to load the hex file into it. PIC microcontroller we are using there. So there we can load the hex file of our program. And also these are the things 16 cross 4 CLCD we are using, tactile switch, matrix keypad, timer module and fan module and a buzzer also to indicate that the time is completed. After that, this is the IDE which looks like in the MPLAB IDE. This is the interface of it actually, we can say that. So this is how it looks. The MPLAB IDE looks like. After that, my teammate Thummaluri Vamsi will explain the remaining part of the project.
Hello guys, this is our project, microwave oven. You are all very well known about what is microwave oven. It is used to quickly heat up food by using electromagnetic radiation to vibrate water molecules within the food and generating heat and cooking food. These are the modes we have implemented in our project: micro mode, grill mode, convection mode, and start mode. In micro mode, used to cook food in a traditional way. Maximum power is 900 watt and maximum time is 60 minutes for cooking. Grill mode, same as a micro mode, for it is used to cook meat and bread. U- Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then user can set the time as per requirements. Start mode. Directly start for 30 seconds countdown. It can be used for short period of time cooking. This is the way of interfacing our modules to the PIC microcontroller. This is PIC microcontroller diagram. You can observe here. Okay, let's go to build our project. I'm opening MP Lab. This is the starting page of MP Lab. Here we are all included the our files, project files. Here a CLCD file, timer file, matrix keypad file. Here this is here the code is there. You can observe all here. Okay, let's clean and build it. Clean it successfully. Build successfully. Let's see the output in PixSimLab. I'm loading X file. Powering on microwave oven. You can observe here. These are the four modes: micro mode, grill mode, convection mode, start mode. Let's see the how the modes are working. Micro mode. 900 watts is maximum power. You can set time here. I'm setting the time 10 seconds. Star for clear, hash for enter. I'm entering. You can observe here fan is rotating when I entered it. Here it is indicating the heating. After time up, buzzer will indicate the signal. Let's see the grill mode. You can set time here 10 seconds. I'm entering it. Here you can observe start, resume, pause, stop buttons are there. I'm pausing it by clicking 5. Here fan rotating the stop. You can resume it by clicking 4. You can stop it by clicking 6. Again we came to the modes. Let's see the convection mode. You can set temperature. If you enter the maximum temperature 180 degrees, if you enter the more than 180 means it will take 180 only. I'm entering 190. I'm entering. We need to wait for 60 seconds. Okay, shall we discuss about all the things representing here? This is the matrix keypad. This is the CLCD, character liquid crystal display. This is a fan module. This is a buzzer, and here you can connect RS-232 pin. Here the PIC microcontroller, which are having the 40 pins. Here you can observe 4 ports: port A, port B, port C, port D. Here you can observe port B and port D LEDs. Here you can turn on and turn off the ports. Here reset button is there. Here you can tactile switches. 7 segment display, everything was implemented in controller. Relays also is there. Okay, yeah, let's set time. Again, 10 seconds. I'm entering it. Start, resume, pause, stop. Same features only. You can stop it, you can pause it, you can resume it, you can stop it. Let's see the start mode. So countdown start from 30 seconds. If you press the 4, it will increase the 30 seconds. It will add 30 seconds again. When you press once, it will add 30 seconds. You can stop by clicking the 6. These are the modes we have implemented. Okay guys, thanks for watching.